Hi everyone, I hope you are doing good. So let's discuss a new DSA question today. Let's understand the question first. The question is given an array ARR of positive integers. The task is to return the maximum of j minus I. J and I are the indexes, right? Subjected to the constraint of ARR of I should be less than equals to ARR of j, and I must be less than equals to j. So basically we have to find maximum of j and j minus I, and the condition is ARR of I must be less than equals to ARR of j, and I should be less than equals to j. That is what the condition is, and we have to find the maximum of j minus I, right? So that is the question. Let's understand this with the example here. So for example, we have this array right here. This is the array 34, 33 and 1, right? This is the array. Let me write the indexes as well. 0, 1, 7, 8, right? This is the index, correct? So now basically we have to find the j minus I, right? J and I are the indexes, right? So let's see here. For example, I is here, right? I is here, and j is here. So in this case, j is 5, I is 0, right? So this condition is true. Now what about this one? ARR of I should be less than equals to ARR of j. So this condition also true, right? And the difference is j minus I is here 5 minus 0, that is 5, correct? Now can we maximize this result? Yes, we can. So see here, if we go this should be j, and so now see here, if we consider this is the j, this is the j, in that case this condition is failing, right? J is greater than I, but this ARR of I is greater than ARR of j, right? This is not less than ARR of j, correct? So this condition is failing. So what we can do, we can move this one over here I, right? So what we can do now, if you check this one, right, this one, so ARR of I is 8, right, and ARR of j is 33, correct? This condition is fulfilling, this condition is fulfilling, and here I is 1 and j is 7, right? So 7 minus 1, that is 6, right? 6 is maximum. So here in this array, if we find j minus I, that would be 6, which is fulfilling the both the conditions. ARR of I is less than ARR of j, and I is less than equals to j, right? So this is the answer, right? 6. So this is the question. I hope you understood this one. I have explained with this given example also, right? So think about the solution. Let me know if you think and if you got any a better solution, optimized solution than whatever we will discuss. Then comment below the video. We will we also get to know about that solution, right? So what in my mind coming is regarding this question, what we can do basically. So let me write it again here. So this is our array, right? 34, 33 and 1, correct? So this is our given array, and the indexes are 0, 1. So now what I will do, I will go with the left min array, and I will go the right max array, basically, right? So I will basically compute the two arrays here. I'm taking extra space. So one way is brute force. So I'm not discussing that. Brute force which will take the n square time complexity, and how that will be the algorithms. Like for example here, I will take 0, and then we will check for the j in the complete array. Then we will go for I here, right? So for example, I is here, and we start the j in this range j, and here we will basically check for these two conditions here, right? ARR of I should be less than ARR of j, right? This condition, and I should be less than j. So I always be less than j, right? If we go with the brute force here, and so we will check this ARR of I should be less than ARR of j, right? And we will store the maximum result j minus I. We will always store in the result, for example, right? This one here. So now if this is in this case, what will be the answer here? It would be 5, right? This is the maximum in this range. So here we get 5, correct? Now after this, what we will do? After this, I will increase the I also. So I have checked this one, right? Now I will go and check for this one here, and in this range I will check for j. So here 8 and here maximum is 33, right? So here we will get the 6 answer, which is maximum. So we will discard this one and we will store 6 one. And then again what I will do, so I am basically explaining the brute force one. So where we are basically checking for all the combinations here, basically that is what the brute force is, right? So each and every number we will say I, and then the rest of the number we will search for the j, right? Which is fulfilling the condition here, correct? So this is brute force which is taking order of n square, so I am not going with that one. So that is the one solution you can consider. And you must always start with the brute force one, explaining the brute force one to the interviewer. And if he asks for optimizing, or you can also suggest, yeah, I can optimize it to order of n also, right? So now I will discuss the order of n approach here, right? Order of n approach, right? And here I will take extra space. So this is the time, right? And if we talk about space, then space also we are taking order of n time, right? So here basically we are computing two arrays. One is left min array. What does it mean? Left min array means like from left side we will compute and we will store the minimum. So here at this stage the minimum is 34. Then again see, check next number. Next number is 8, which is minimum than the last number. So I will store 8. This is 10 is maximum, right? 10 is greater than 8, so I will say 8 only, right? Because from left side we are maintaining the minimum number, correct? That is what we are doing here. So now see here, next number is 3. So 3 is less than 8, right? So 3, then we are getting 2. So here 2, and then 80, right? 2 is less than 80. So here 2, 30 is less, 2 is less than 30, 2, 33 is greater than 2, right? So we will maintain 2 only, and 1 is less than 2, so we will update 1 here, correct? So this is the left min array. Now compute the right min array here. Right max array. So in right max array, what we are going to do, we will basically start from the right side and we will maintain the maximum number, right, till that particular index, right? So see here, one last, so I'm here computing from the right side only. So here maximum is 1, right? Maximum is 1, and then after that we are getting 33, which is basically greater than the 1. So we will store 33 here, correct? Then 30 is less than 33, so we will maintain maximum here 33, right? Then we got 80. 80 is greater than 33, so let's store 80. Then 2 is less than 80, so we will let's maintain the 80 here, right? 80, all 80, correct? And 34 is also less than, so we will say 80 only. So till now we have computed the min and max array. So now I will check for this condition here, and this condition I will apply on the left min and right max. So what I will do, I will check left min of I should be less than equals to right max of j. So this is the condition I will check here, and see here I would be my 0, and j would be 0, and here this condition is fulfilling. So what I will do, I will increase the j here only. So j1, I will go j here, right? Then by this point I will check here if j is 6, right? In that case it will fail, correct? It will fail here because this, see, left min of I, that is 34, not less than equals to 33, right? 33. This condition is false. So now what I will do, now I will increase the I here. Now I will increase the I, and I say I is 1, right? And then again I will check the condition. So left min of 1, that is 8, right? Less than equals to 33, right? 33, right? That is right max of 6, j, correct? So this is fulfilling condition. So then again I will increase the j here, 7, right? And each and every time I will basically update my result, right? Maximum result, whatever I have, right? With maximum, correct? So that is what. So the algorithm is as simple. So I hope you understood it. So see, this is the simple, right? So what I will do, I will basically run the while loop here, right? So here I must be less than n and j must be less than n, right? And in this while loop, what I will check, if left min, this would be my if block, where if left min of I is less than equals to right max of j, it means this condition is true. This condition is true. So what I will do, I will basically increase the j. So I will do the j plus plus, and here also before j, what I will do, I will basically store the result here. So we can say res is equals to maximum of res and j minus I. So each and every time I will calculate, and then I will increase the j plus plus here, right, in this block. Else what I will do, if this condition is failing, then I will say I plus plus here, right. I will increase the I, this index. Why I am doing this one? See here, because so here if I increase I here this way, right, in that case I am minimizing the window, and if I am increasing the j here, right, j plus plus, in that case I am maximizing the window. See here, the window starts from here, right, this one only. Then I will increase j. So the window is starting from now, like we are increasing, right, correct? We are here increasing till now this one, right, and here it is failing. Here it is failing. So what I will do? The window is this one, correct? So window got increased to this one, correct? So this one, right? Now what I will do? I will basically, so now condition is failing, so I will minimize this one, right? So I will basically go here and I will check this one only. So my I is here now, correct? So let's remove this one. So now I am basically minimizing the window by increasing the I, and when I increase the j, it means I am expanding the window, correct? So that is what we are doing here. So I hope you understood. This is very simple algorithm. So let me take you the C++ code. I have added the C++ code for this algorithm as well. So see, this is the code I have added for this algorithm, whatever we have discussed. So here I am taking one basically left min and right max, right? I am taking left min, this one, and right max, two array of n size, correct? That is what we have calculated here. For example, this left min and this is right max. Right, left min is 34 to 1, right, and right max is 1, 33, 80, 80, 80 and 80, right. So this is the two array I have basically taken here, two vector, and here I am calculating. This is for the left min, right, and this code is for the right max. So, right, here we are computing the left min array, and here we are computing the right max array, right. I hope you understood this logic. It is very simple. And then after, once we are done with this left min and right max computation, then I will apply, I will take I and j at 0th position and the result, right, these three variables, and here I will iterate till either one of the arrays complete, right, or correct here, and then I will check the condition here. Left min should be less than equals to right max of j. Left min of I should be less than equal to right max of j, correct? And if this condition is true, it means it is fulfilling this condition, and error of I is less than equals to error of j. So what I will do, I will update my result here with the maximum value whatever I have in the res variable, and j minus I. I will compute this j minus I, right? Which one is greater, I will store that into the result, right? And I will increase the j plus plus here, correct? Here I will increase the j plus plus. Else, if this condition is false, then I will increase the I. It means I am basically minimizing the window, and when I will increment the j, in that case I will maximize the window, right? That is what I am doing here. And this is the while loop, correct? Once we are out of this while loop, it means one of the arrays ended, right, completed. Then I will return the result here, right? I hope you understood the code. Let's run it for one of the use case. Let me clear this out. So if we run this one, so here you see we got maximum result is 6, right? That is why we got 6, that I have already explained you, right? And here if we talk about the time complexity, so it will take order of n, right? This will also take order of n, and here this will take order of n, correct? And here we don't have any inner loop, so the total time complexity would be basically order of n only, right? Here because we will add, correct? We can process them parallelly as well, correct? So the maximum time complexity we will get here order of n, right? So the brute force one was taking order of n square, right? And we optimized this one, we optimized to order of n, right? But keep in mind that here in order of n, we are taking extra order of n space as well, right? And here we are the space is order of 1 only, right? Constant space. We are not taking any extra space in the brute force approach, right? So I hope you understood the problem. Yeah, that's all for today. See you next time. Till then, keep learning and keep exploring.